Okay, so here's this thing that I ordered, and it says it's a 40 watt uh Qualcomm 3.0, which to me means you can get, really high wattage running at 12 volts or 9 volts or 5 volts when your device supports Qualcomm 3. I've only got one device that does. It's a battery bank, but that's super beneficial for charging that particular bank in terms of how long it takes to charge. Um, and then there's some other ratings here that are a little suspicious after looking at this thing. But it says it does 3.5 amps on any single port. Um, it kind of implies that all the ports are Qualcomm 3.0. That would actually, as it turns out, be not advantageous. The reality is that this thing has a single Qualcomm port on it. Um, it's located right here. You can see it is finishing a charge on this battery bank. Um, and it's running at a rounded up 12, probably 12.5 volts and 200 milliamps. So you get voltage in a single digit, and then you get a 2-digit amp rating. Um, the entire thing can do 35 watts. If you do more than 35 watts, it will fall apart and just start rebooting. So you've got really stable measurements that I verified that it's actually accurate. This or accurate within 1 digit, right? We're doing 5 point something volts and we're doing 1.1 amps. All of this stuff measured pretty stable, and I consider these reliable enough. Um, but if you're using this Qualcomm port on a hungry device, it can certainly saturate, 18 to 20 watts off the power system, and a separate you've got separate feeds for the Qualcomm versus all the other ports. I think what is really happening is that there's a 35-watt rating on the entire supply, which means you could theoretically do 7 amps across all the ports. There's nothing that's going to regulate it, from what I can tell, to 2.4 amps per port, but the likelihood of any USB device accepting 2.4 amps to the battery is pretty low. Then you've got the Qualcomm port, which really can deliver, 18 to 20 watts, depending on what voltage it negotiated. And that's on a separate rail within this device. So um, at the end of the day, you get a ton of convenience, and you know the reason I find it so convenient is, say you may not realize, but say you have a USB-C device, and normally you're going to want to charge these with a USB-C charger. But say you plug it into a fancy charger that has a Qualcomm port on it. Well, oftentimes you actually don't get the performance that with some devices, and whatever the hell their USB charger is, you won't get the same performance out of a Qualcomm port than you will out of other ports. So like we're getting 1.3 amps here, which is a slow charge by this phone's thing, but we're getting about the same performance ish on just a normal port. Um, if I grab a different phone, which I've completely misplaced here. Yeah, so if I grab a different phone, this is just another USB-C phone. Um, and we plug it up. Well, we're still not going to get the performance we got with USB-C proper. This thing's not going to charge nearly as fast. We're doing maybe 7 watts right now. USB-C will negotiate 12 volts, but you can pull like 3 amps. So this phone came with a 27 watt charger in it, and both these phones charge like crazy, off USB-C. But if I put it in a fancy Qualcomm port, no, it's gonna make a liar out of me. Nah, well, you can see it's definitely negotiating around. Okay, I'm gonna give this a pass. So maybe the USB-C stuff isn't nearly as bad. Shit. Everything else, everything else I've already charged up. I guess my point is though, I've seen interactions with Qualcomm 3 ports where you get a much shittier rate, and if you put it in just a normal dumber USB port, you'll get a much better rate of charge. So you pick up convenience in a few different ways here. One is when you plug a device in, you can estimate sort of the state and how rapidly it's going to charge. Again, I believe these readings here, and then two, for like especially for something, if you have an actual Qualcomm device, or if you had bought the USB-C version of this, which I wish I had. I didn't see it. I saw this and I was like, I'm gonna get that, like, because I just want readings. But you really get to see how rapidly something's charging, and I think that's a huge convenience. I think overall this thing is worth the $25 or whatever. It's super generic. There's probably a bunch of different versions of this. Um, as long as you don't overload it to where it falls apart and you'll just see the screen rebooting, and I might have some video of that and you can hear me hem and haw. Um, then I think it's fine. Other than that, it's crusty as all get out on the inside, and I'll I'll play some internal videos. You can watch me try to act like I know what I'm talking about on the inside. But yeah, I think overall, like I am gonna use shit out of this. It'll get really hot. It can pull 35 watts. At 35 watts, it'll begin to reboot, and that kind of sucks. But the chances of you saturating these ports with 35 watts, in other words, if you put 7 things on here that are all pulling an amp, I'm going to find the likelihood to be really low that they're all going to be pulling an amp, which would be 7 watts per port. 7 times 7, that's going to destroy it. The more likely scenario is that you have a bunch of things in here, and some are pulling 1.6 amps and some are pulling, half an amp, or 200 milliamps, and they're near the end of their charge, and you're never going to saturate this entire power system. But if you're using the Qualcomm port, you can easily overpower the power system, and this thing will just start rebooting. Nah, I mean, it might have been more thoughtful if they had made it use less power, or limit one or the other, right? Limit the USB bus or the Qualcomm bus, since it's like 2 separate feeds, so that the power system doesn't fall apart. But they didn't, so whatever. That's probably the biggest downfall of this thing, is that, if you plug something in, it might start rebooting, but the likelihood is that you're just asking it to do too much work, and you're not going to run into that often. And even with that scenario, just unplug shit or move this guy to here, and it'll just limit the rate at which you're able to pull watts out of this thing. And you'll probably be fine. Especially like if you're going to bed and you're like charging a battery bank and charging a ton of other shit. Like, I don't think this scenario is going to happen too often. But when they say 35 watts, they mean 35 watts, and this thing falls apart at 35 watts, and there's no smarts in it to keep it from falling apart and rebooting. I can't remember if I already mentioned it gets hot as shit. Don't put it under blankets. Don't, you know, like this is an electronic device, and it can pull close to 35 watts. It's going to dissipate a fair amount of heat. I measured at 1.63 degrees on the back here. That's 63C. So at that point, that is a temperature that you can't keep your hand on. So yeah, just don't, this or any other multi-port charger, that's rated up in the tens of watts. Like, just, you don't put them under blankets. You put them on an area where they can breathe. So yeah, I think it's a neat little device. I'm gonna hand pluck some other video, and I don't know, play it after this, and I do tear it apart. It was a real pain in the butt to tear apart, but I think more. I would like to see more devices like this. I think it's way more telling to use a device like this to determine state of charge. A great example, man. This thing has been charging for a while, this battery bank, and we can trace that cable back to here. Really, it's just done charging, which agrees with the LEDs there. You plug it back in, maybe it'll pull a milliamp, maybe it won't, but it really is done charging, and you can see it. Derp. This battery bank, yeah, as I said, is a Qualcomm 3 battery. Oh, that's not even plugged up to my battery bank. 0.9. Well, yeah, no, that's an amp. I was gonna see if this Nexus tablet over here doesn't play well with the Qualcomm port, but I'd say that's roughly similar. 0.9. Anyway, you decide. But yeah, I think the convenience factor of this, I especially want to see the USB-C version of this. Yeah, so I don't know. I don't know if anybody's going to find this useful. I will pick out the internal piece of the teardown. The rest of the video is probably going to be pretty dry, but there you go. Okay, so total power is rated at 35 watts. So let's pull 15, that was like 15 watts. Let's pull that off and see now if it can sustain. Three, 4.5 amps times 5, maybe 20 watts. Okay, that's sort of interesting. So it is. So it's just the entire power system being overloaded, I guess. So in this case, as soon as we negotiate 12 volts and we start pulling 12 or 15 watts. No? What's happening? Now it's almost, well, sort of. Yeah, there it goes. So I think in this case, which is lame, if we just put the charger where it can't negotiate a higher wattage, that's this guy. Then yeah, can we total here? 1, 2, 3, 4, 5. Yeah. So now we're just kind of just under the threshold. The problem is, yeah, nothing. The between the 7 ports and the Qualcomm port, the total power system is oversubscribed. So if we, if you actually have 3 devices that are uncharged that will use between 1 and 2 amps a piece, and then you have a Qualcomm device such as a battery bank charging on this single Qualcomm port, the Qualcomm port being able to pull so many watts, close to 15 watts, means you really can't charge other devices on the USB ports that are gonna pull any amount of amps. Oof, 3, almost 4. Yeah. Yeah. So I mean, it's still a usable device, but that's just kind of sad. That's just kind of sad because you want the other way around. You want the power system to be bigger than what power actually gets used. You don't, like it's underbuilt. Um, the yeah, that's too bad. Um, also this device was rated 40 watts on the website, and right here it says 35 watts, and 35 watts is about what we're seeing. Maybe you can do 7 amps. This is unbelievably hot too, actually. Ooh. But yeah, this is a combined, yeah, total power 35 watts. So yeah, man, that's pretty hot though. All right, who fell off? Okay, there it goes. I had rebooting problems before I was oversubscribed though, so I don't know. 1, 2, 3, 4 amps. 5. Ooh, almost 5 amps. 6 amps. 7 amps. Yeah. No, maybe it is almost pushing 7 amps. Six, 4.8. Or maybe 5 amps. Shit, I can't math. Yeah. Neat idea, bad implementation. Such a fucking pussy. Look, we'll just set it on a big old piece of aluminum. All right. Let's see if I've got a let's just take a couple measurements. You can never be too safe here when trying not to electrocute yourself. No, I mean, I mean, I don't really fuck around. Where was that cap? Kapow! 12 volts. Uh-huh. Kind of looks like it goes from here to all the way over here. And it is discharging. Let's see, is it discharging on its own? Is it discharging through? No, I don't see. No, I don't know where that goes. No, it doesn't look like it's really discharging on its own. So right now it's just discharging through my multimeter, but I don't. I mean, but you can see. I mean, you still got fucking voltages here and there. Yeah, I think that's the cap. Oh, no. I don't have any wires or nothing lying around here. How does electricity even work anyway? Oh yeah, I saw a spark. I saw a spark. It's still got 9 volts. I mean, that shouldn't really scare us, right? But oh yeah, little spark. Anyway, that was a 400 volt cap, so I'm not gonna give myself any grief for taking any precautions here. And I'm pretty sure I got the. It's kind of hard to see. Yeah, I'm a pussy. I know. I think that's right. That guy to that. Yeah. All right. Anyway. All right. So there you go. Now if somebody dies, it'll be on camera. Okay. You guys can just enjoy yourselves. No, I got horrible camera work here. So what's going on here? This is some sort of. Well, first of all, these heat sinks, these are big and beefy and nice. There's plenty of them. I don't know. I don't know exactly what all is going on with this circuit, but it does look like it's got some filtering stuff for electrical, that fuse in there. I don't know, 35 watts. Whatever. Is it actually replaceable or is that soldered in? Either way, I think you could put in a new one. Oh, 3.15 amp, 250 volt. So it's actually labeled on the whatever, a 15 amp, 250 volt. Or do you think that's 3.15 amps? Is that a normal fuse rating? That'd be like 750 watts. I can see more than one coil inside the transformer there. So are there multiple whatevers? Is that a Molly whatever one of those? Yeah, and there's a couple dudes. So I guess all of everything on this side is high voltage, where of course I'm holding it from, and then everything on this side would be low voltage. And the only thing that is really bridging across there is the transformer and that guy. Yeah, and then we have some high voltage blah and plenty of separation and some routing through there across that guy. What else across there? Is that just more transformer? Oh no, the little blowout dude. All right. Low ESR caps, no name that I can see. All pretty high rated stuff, whatever. I swear it looks like a bunch of stuff isn't populated, but what would those be? All right, so then this is like a wax hard paper. It's getting close on this chip. A TM1622. Some sort of jibber jabber. Aha, there's the STM32F. So there's your microprocessor. I wonder what this big chip is then. Those are a bunch. I'm guessing those are all shunts. Each one of these big dudes right here for measuring current. And yeah, it's pretty neat. So I bet you this is just some standard off-the-shelf thing that does current measuring and voltage measuring and all that stuff. Or maybe that's the display driver. I see lots of I/O going to a lot of pins, so maybe that's probably the display driver. And then we've got, yeah, so we've got the microcontroller. So probably all the analog to digital shit on the microcontroller is measuring current across those shunts. And oh man, the whole thing's just kind of a mess here. All right. So I reckon I'll take this off and we'll go in. See what's on the front. So interestingly, the place that was getting hot on the back, I reckon was on the side, and then here we had a lot of heat, which is going to dissipate in that direction towards all of this stuff, because the hot air is going to convect up into that area. So that's maybe a little but I don't, these are nice silicone wires. These feel good. They're quite flexible. And at least it's been my experience with those little silicone wires that they typically have a really high strand too. They're super flexible. And 1, 2, 3, 4, 5, 6. Did this come missing a screw from the factory, or am I just so quick? Yeah, I don't think this screw is ever in here. The high strand typically also means low loss. And I bet you these are power and ground. So like, I don't know. Oh, it almost looks like over here, they've got power coming in on multiples, right? So we got the Qualcomm 3.0 port. And then That's D plus. Is D minus there, or they just send ground in on this side? But oh man, that's crusty. That's crusty as fucking shit. But that kind of makes sense. So we're getting probably like this guy, one of these is specialized for powering the one Qualcomm port, which means all the other ports are probably sharing their output. And the spec said what, 3.5 amps, or was it 3 point? I think it was 3.5 amps per any one port. So I do wonder if that infers that you have 2.5 amps per, or excuse me, 3.5 amps across all the 7 normal USB ports. So that's kind of weird. But whatever. I mean, that's not the end of the day, right? And then I don't know. Can we get in there? Eat it, Moe's. My thought was that maybe one of these is a 12 volt and a 9 volt, but I don't see any way that the shit gets switched here. Yeah, I don't know how the electricity works. I really don't. All right, so we'll get a look at the we'll get a look at the board. Front of the board. We've already seen the back of the board. I mean, it's crusty as hell, but I think it's pretty neat. I'm trying to think with what we've seen so far, where would I integrate, would monitoring voltage on just these leads be enough for us to stick in our thing that is monitoring ports, or I don't fucking know. All right, so that's the backlight. Yeah, and just on here the whole thing is just really just mounting. This display has crust on it. There you go. There's no cover, so that could be my crust. Yeah, whatever, man. I think it's all right. So I guess, I mean, all the magic then is gonna be in this guy, and that is a little microprocessor. So I don't know. Maybe that's the type thing we could pull the firmware off of and reverse engineer, and then maybe one of these unused pins or something could talk to something if we wanted to wire shit in there. I'm not exactly one of those hacker people. Some of these that looks a little dry. Some of these solder joints aren't. I mean, it's on there though. Oof. What a mess though. Yeah, so that's what you're getting. That's what $25 buys you. He's really, man. That just, to me, the crust factor is pretty, it's pretty real. Somebody had to hand solder these though. How close can this stupid camera get? I mean, that is crusty. Yeah. So, not seeing, like, anybody see any reason for reboots here? God, those things are in everything. Those STM32Fs. That actual, no. Yeah, it's just, ugh. What is, this is crusty as all get out. Alright, so the shunt, like, these shunts have got to be, like, that is a current shunt, I assume, right? So you measure voltage on one side and the other. I guess you measure the voltage across it, and that gives you how much current is flowing. So are those all, were those all through hole then? Yeah, actually, yeah. So, okay. Yeah, that's kind of cool. So at least the connectors are all through hole, which I think I'd prefer in this setup. Just stronger. So yeah, I think I'm gonna go with based on what they've been saying, you're gonna be limited to 3.5 amps on all the USB ports, and then you're gonna have the full 3.0 port throughput. So whatever Qualcomm 3.0 supports, which I think is like, hell, it was right on the thing. I guess I'm already losing my mind here. Yeah, 12 volts, 1.5 amps, 9 volts, 2.3 amps, or 5 volts, 3.4 amps. So that 3.4 amps is going to be dedicated on that one. And then DC 5 volts, 7 amp, or 2.4 per port. Okay, so 7 amps across the board and 2.4 per port. Which, does that align with what we see here? Because for real, like this would be the Qualcomm thing. And we're doing, what would we say? 3.4 amps is the most that it can do. Using this high strand wire, I would say, yeah, they can deliver that safely across this wire. And then if you double that, they're probably delivering all of the other shit across these, or maybe they're just pushing 7 amps across this. Now I'm kind of curious. I want to know what voltages are across this pair, this pair. Like, I'm assuming In my mind, I was thinking the 3.0 port, this would be doubling up on the wire for the USB stuff, except that I don't think these are the same point here. So I don't think I believe that anymore. But anyway, could you deliver 7 amps across this wire? I'm thinking probably. Oh, do we have a... It's definitely the silicone wire. Does it have a rating on it though? This is where my camera is really sucking, because I can almost see this better with my old eyes. And does that go through? Oh. 3 volts. Man, I don't like... Oh, well, there you go. So it's actually labeled on this side. These wires are not ideally done. So we've got a shared ground plus 5 volts. So this pair is going to be able to deliver 7 amps, and then we have a 3 volt. Oh, okay, D minus and D plus. So this pair is going to deliver your 3.0, and then there's a 3 volt supply also. So it probably just shares. I wonder if all the grounds are tied together. There we go. So let's see some ground. Oh yeah, really? That would be the ground on the 3.0 port. Seriously? Okay. Let's just make sure. Interesting. So what if we get ground here? Okay, so none of these dudes appear to be... They all appear to have isolated ground, or this isn't grounded. Would that be better? Oh, that's a bit smashed. Would that be better? Is it better to have all of your USB shit not grounded? I mean, that's kind of what I was talking about with that switch that I have. Is I worried about ground loops and differences between the potential of 2 different ports. Yeah, so these are all isolated from the actual ground plane. That is going to that ground. So, but we already checked, right? The 2 grounds weren't connected. So we've got let's get in frame. We got this guy, and then we're going with this is the other minus. Yeah, and it's just not. We also like. It kind of looks like the power is flowing up through this via. No. Yep. No. Okay. What's that? Is that USB data? And like I said, I don't know what the demons in USB. I don't know how anything works. Let's see which one. Any of these. That's our ground. Sure, 5 volts. Right there. Huh. All right. Well, there you go. There's a monkey trying to describe the electricity. But maybe that'll give somebody enough information to draw their own conclusions about this stuff. Yeah, I'm gonna throw this thing back together and let's see if we can find a really shitty cable, and then we'll wrap this up.